Today, we're going to be talking about energy. You know what? All the energy in chemistry is right there in the chemical bonds. That's it, pretty much. Well, there's, some other stuff, but I guess. The chemical bonds. So write this down. Write this down. Here are two molecules. Which one do you think has more stored potential energy?
The second one.
First one.
Left or right?
Right. Left.
Why do you think that?
There's still bonds.
More bonds. Okay, now, let's look at the bonds in here. Which one do you think has more stored potential energy? The single bond or the triple bond?
The triple bond.
The triple bond is correct. Remember when you were doing the Mole Airlines, they were talking about TNT? Yes? TNT is a nitrogen-containing compound. Nitrogen-containing compounds frequently have triple bonds. Which may be why when the energy is released in TNT, it's a... Okay, let's talk about how the chemical bonds are transformed into different types of energy. When something explodes, what type of energy energy transformations can you see? The energy becomes what? You know your types of energy. Give me one type.
Thermal.
Thermal is correct. So it's thermal energy. Anything else?
Chemical energy?
No, not usually. Kinetic energy, because certainly things are moving around.
Potential energy?
Not so much.
Well, it's frozen.
Tell me what else? Any kind of energy.
Light energy?
Light. Very good. Light. Anything else? So far, one person is giving me all the correct answers. Let's find out. And he got the easy ones. Anything else? Anything else?
Potential.
Sound. Sound, which is
Sound.
mechanical energy.
Solar?
No, not so much. Is that enough?
No.
When atoms break apart, is there a sound?
When atoms break apart, is there a sound? Sometimes, not all the time.
Like an explosion?
Well, yeah. That is one of the sounds. Okay, so here we go. We talked about the kind of energy that enters or exits a chemical reaction. There's some thermal energy. This is a pictograph of the thermal energy leaving a house. What do you notice about windows?
They have one.
They have a lot of energy coming out. Sound energy, light energy. Hey, we forgot electrical energy, didn't we?
Oh, yeah.
Chemistry is a big producer of electrical energy. How?
batteries.
Batteries is correct.
Are you going to write that on your board
Hmm?
for the activities for us?
Did I write that?
Yeah.
Yeah, I was kind of in a hurry. All right. Okay, writing all this. Do you know what internal energy is? Take that as a no. Okay, ladies and gentlemen, enthalpy is a fancy term that in Chem 1 you should think of as the measure of the heat content in a system. And usually the system is the chemical reaction that we're studying. So it's the heat lost or gained in a chemical reaction. Remember, a chemical reaction is the reactants producing products. So it's the heat lost when the reactants become the products, or the heat gained when the reactants become the product. And we measure it in the change in heat. It is an extensive property, which means it depends on the sample size. We've talked about intensive and extensive about 6 times without making you write notes about it. Intensive properties mean that they are independent of the sample size. Name an intensive property. Density. Look, you went for the hard one right there. Density is equal to mass over volume. Mass and volume are both extensive properties, but when you put 2 extensive properties together, they make a intensive property. Name me another intensive property. Color. Another?
Texture.
Color. And I'm going to defer texture.
Melting point.
Thank you. That was a great one. Melting point. And then its cousin, boiling point. All right. Its twin brother, freezing point. Okay. Now, name me 2 extensive properties that...
Wait.
Okay, we're not going to use weight because in chemistry we have to use mass. But mass would be one of them, and you can't use volume. I already did.
Temperature.
Temperature?
Temperature?
I just said that.
I know, I didn't
That's
see
not
it.
one that we're going to mess with either. I want you to give me length. So I give it to you. All right. Enthalpy cannot be measured directly. How come? Because part of this is, part of enthalpy is the internal energy of the chemical reaction, and energy transformations are happening all the time. It would be really, really hard to just stop everything and say, excuse me, I need to take an inventory of all your energy. Can't be done. What we can measure, though, is how the heat changes. So we're going to define enthalpy as the change in heat. Its units are measured in joules per mole. Joule is a unit of energy. All right. So your reaction that you need to look at from your star chart is the change in enthalpy, the heat lost or gained in the reaction, is equal to, okay, everybody find it first. Where is it? On the bottom of a page? Okay, you got it? All right. Now, the change in enthalpy of the products minus the change in enthalpy of the reactants. What the heck is this? It's an F that stands for the change in enthalpy of formation of the products. This is getting really weird. And then what is this thing? No, it's said ought. All right, now you're getting really, really odd. The change in enthalpy of formation ought. Okay, ought stands for standard conditions. Standard conditions. You know why? Because we all have to be on the same field. Wouldn't be right for, I don't know, Johnny to do an experiment at 50 degrees Celsius. Would that be hot or cold, by the way? Hot? About what temperature is that in Fahrenheit? Anybody know?
What?
50 degrees Celsius.
It would be,
About 130.
that's
About
what I was gonna
130.
say.
Johnny do it at 50 degrees Celsius while Sally does it at 25 degrees Celsius. Hot or cold?
Hot.
25 degrees Celsius.
Oh, cold.
Room temperature.
Oh, hot.
Room temperature. Okay. So it's always the delta heat of formation at standard conditions of the products minus the delta heat of formation at standard condition of the reactants. Can we make that simpler? Yes. Delta H is equal to the enthalpy of the products minus the enthalpy of the reactants. Here we go, moving on. Use the table of the enthalpy values to determine the enthalpy of reaction. You should have a book on your desk. If not, send somebody in your row who isn't going to be in the camera. Thank you. To go get books. The rest of you, find the chart in the appendix. In the appendix. Which is not in the chapter about enthalpy. The appendix is in the back. Once somebody finds it, yell the page. What? 912.
Oh, wait, there's different appendixes.
Oh, they are. Why? Oh, there's lots of appendix. That's, yeah, 912 has an appendix C, but not the one you want.
502.
No, it's gotta be back in the back. Found it. 921, which in my mind looks just like 912.
Beach wear.
All right. Got it? Okay, please note, you have 32 seconds to tell me what you notice about these values.
They're all different.
More negative.
Most of them are negative. That is one pattern. It's not the pattern I'm looking for, but it is a good pattern.
That's the one.
They have a lot of decimals, still not the pattern.
There's several zeros.
There are several zeros, is what I want you to look at. Now, find the pattern in the zero values.
It all has to be
They're
this.
diatomic
They are all diatomic molecules.
or aluminum. That's-
They are all, you're close, come on, you can do it, you can do it.
Monometal.
They're all,
This is how you
Ed's
One atom.
close. Ed, really close, looking at the right place.
One metal.
They're all,
One element.
they're all elements. They're all elements. All right, so this is the deal. The delta H of formation is the energy content that went into forming the compound. Find CO2.
Found it.
Got it. So what they were saying is when you took some carbon and added half a mole of oxygen, I'm sorry, when you took some carbon and added oxygen and it made CO2, the heat involved in that was negative 393.5 kilojoules per mole. In order to form from the elements carbon and oxygen into CO2, this much energy was released. We are assuming that carbon and oxygen were formed before we were thinking about chemistry. So we're saying they've always been here. So all elements are equal to zero. Write this down. All elements, and you will notice even if they are diatomic, have a delta H of formation at standard conditions of 0. That makes these problems a lot easier. All right, here is your first practice problem. Quickly write down this practice problem. Just write the equation, zippity-doo-dah. The question they want answered from this is, what is the change in enthalpy for this reaction? And to do this, you look at the chart. And you remember that the delta H is equal to the enthalpy of the products minus the enthalpy of the reactants. So, these are the reactants, these are the products. Let's look at the chart and find the delta H of formation for carbon dioxide. It is negative 393.5. I'm cutting it off at 1 decimal. And to that, I need to know and add the delta heat of formation of nitrogen. It is 0. Then, these are my products. I am going to subtract my reactants. My reactants are the CO, which is negative 110.5 kilojoules, and to that I must add the delta heat of formation of nitrogen monoxide, which is positive 90.3. All right, now I get lost sometimes in the negative signs, so I do these in baby steps. I'm going to do the math in here, negative 393.5 plus 0 is negative 395.5. From that, I'm going to subtract the sum of negative 110.5 plus 90.3, which is,
Negative 101.47.
it's negative, it's positive. So negative 20.2.
Oh, I see.
All right, see, that's the problem with these. So, in my calculator, I'm going to put negative 393.5 minus, and then I'm going to put this in parentheses, negative 20.2, and my answer is the delta heat of reaction for this reaction is negative 373.3 kilojoules per mole. This is talking about the energy, the heat content of the system. Hey, can you have negative energy?
Yes. No, no.
No. I see a negative sign right there. What should we think when we see this negative sign?
Change
What
to
does it mean?
positive.
Nope.
Just means you want to-
Nope. Anytime you see in any one of these problems a negative or positive sign, it tells you the direction of flow of the energy, just the direction of flow. And a negative means it's exiting. So 373.3 kilojoules per mole is exiting this system. If you were to touch it, what would it feel like?
Cold. The product of reactant.
No, this whole thing is the system. If it was happening in the beaker, and you put your hand on the
Oh,
beaker, it would feel hot, because it was coming out of the system, going to the beaker, and from the beaker to your hand. It would be hot. The beaker and your hand would be part of the surroundings. All right, do this on your own. Oh wait,
That's the
or
same
I could
problem.
advance the slide. Now do this one. The states of matter matter.
I get it.
Oops, my bad. Turn around. Yeah? All right. All right, one more. Now, this is a timed event. You done? All right. Moving on. Why are you confused? I wish my ink would come back, but it won't. All right, you're going to do this next Friday. So would you please, you don't have to draw the picture, but you do have to. All right, we're adapting an AP Chem lab 4K. And the AP Chem lab is really used the same way. I'm going to give you a calorimeter that is quite complex. Are you ready for it? It's 3 coffee cups. You take 2 coffee cups and you put them together. See, here they are even in this picture. Here's 1 coffee cup sitting in another coffee cup. Then the 3rd coffee cup, I'm going to cut the bottom off and make a cap out of it, poking a hole in the thermometer. What you're going to do is take NaOH in 1 container and HCl in another container, pour them into the 2 coffee cups, pop the top on the coffee cup lid, poke the thermometer down there, give it a little stir, and wait. Wait until the temperature stabilizes. Now I want to ask you a question. If the thermometer started out here and it goes up to here, was heat given off by the system or absorbed by the system?
Absorbed.
It was given off. It was given off. But if the temperature started here and it went down to here, it would be absorbed from the surroundings into the system. Get it? All right, we'll do this another day. You know what? You need to write all of this down, including this. This is really necessary for your assessment, which will be on Thursday, March 7th. It will be an assessment, not a test. Who heard this? Anyone? No redos on the assessment. Ready, set, write everything. And sketch as well.
End product, okay, just as the end product.
Yeah, that is the most confusing thing about it.
Yeah, but the end product is what counts.
The negative sign of the
Yeah.
delta H.
Right.